Question 2. Given that fx is 1 over x, A. Sketch the graph of y equals fx plus 2 and state the equations of asymptotes. B. Sketch the graph of y equals f open bracket x plus 2 close bracket and state the equations of the asymptotes. Write column vectors. Describe the translations in part A and B. What does the graph of 1 over x looks like? If you have the y-axis and the x-axis, the horizontal asymptote is y equal to 0 because the equation 1 over x is actually y equals 1 over x plus 0. So C is 0. The vertical asymptote, we set the denominator to 0, so that's x equal to 0. Then we look at y-intercept because we need to find the y-intercept. So for y-intercept, that means when x is 0, what is y? When x is 0, y-intercept is the vertical asymptote. Anyway, so that's the vertical asymptote. So no interception there. When we need to look at x-intercept, so when y is 0, again is the horizontal asymptote. So that's what that is. So we don't have interception in both x and y. Now we can sketch the curve. Remember to draw your horizontal asymptote, hidden lines, and to draw your vertical asymptote. This is x-axis, that's y-axis. And the graph will be coming from negative infinity of x to negative infinity of y, positive infinity of y to positive infinity of x. And that's what the graph looked like. For question A, we just raising fx by 2. So we're just raising that graph by 2. So we'll have a new line of asymptote at y equals to 2. Question A, we need to sketch the graph of y equals fx plus 2. This graph is actually will be written as y equals 1 over x plus 2. Now we need to find the horizontal asymptote. The horizontal asymptote is when y equals c. So y equals to 2. That's the horizontal asymptote. The vertical asymptote, we set the denominator to 0, so we set that to 0. Vertical asymptote is x equal to 0. This is the y-axis. The equation of the y-axis is x equal to 0. This is the x-axis. The equation of x-axis is y equal to 0. If this is 1 and that's 2, we can now draw the horizontal asymptote at y equals 2. So that's the horizontal asymptote at y equals to 2. We now need to draw the vertical asymptote at x equals to 0. Then we need to find a line of intercept. We need to find the y-intercept. There's no y-intercept, that's the horizontal asymptote. What about the x-intercept? So that's when y equals to 0. So if we come to the equation, we set y equal to 0. So you get 1 over x plus 2. Multiply both sides by x to get rid of the x denominator. So you get 0 times x is 0 equals 1 plus 2x. And then so you get 2x equals minus 1, x equals minus a half. So we have minus a half for the value of x. So if this is minus 1, minus 2, minus a half is here. So that's the value of x at minus a half. So that will be the x interception. So you always have to find the 4 things. 1, the horizontal intercept. 2, vertical intercept. 3, y-intercept. And 4, x-intercept. Now we can sketch the graph. We know the graph is coming from the negative x infinity. And it will be approaching x equals to a half, minus a half. And then approaching the line x equals to 0. Also, it will be coming from positive y infinity going towards positive x value. The intercept is this point here where minus a half, comma, y0. And the graph we just sketched is y equals 1 over x plus 2. Question 2b. Sketch the graph of y equals f open bracket x plus 2 close bracket and state the equation of the asymptote. So what we need to remember is the fx itself, y equals 1 over x. And now we don't have fx, we've got fx plus 2. So that means y equals 1 over x plus 2. So that's the graph we're dealing with. Let's label the axis, y-axis, x-axis. The equation of the y-axis is x equal to 0. And the equation of the x-axis is y equal to 0. First thing we need to do is to find the horizontal asymptote. And that is y equal to 0 because this is plus 0. So that's y equals to c and c is 0. The second thing we need to do is find a vertical asymptote. Therefore, we need to set the denominator to 0. So the denominator is x plus 2. So x plus 2 equal to 0. X equals minus 2. The vertical asymptote is x equals minus 2. So the next thing we need to do is to find the y-intercept. Number 3. The y-intercept is when x is 0. So when x is 0, we know that if you put x equals to 0 here, so you get y equals 1 over 0 plus 2. So we're putting x equals to 0 there. And therefore, we get y equals a half. So when x is 0, the y-intercept is y equals a half when x equals to 0. Number 4 is to find the x-intercept. So to find the x-intercept, we want y to be 0. When y equals to 0 is the horizontal asymptote. Therefore, there is no intercept on the x-axis. So now we can sketch the graph. But first we need to draw the asymptotes that we need. That's the first thing we need to do. So the first asymptote is y equals to 0. So we just draw the line y equals to 0 here. And then we need to draw second asymptote as x equals to minus 2. So this is minus 1, minus 2. So if we draw the x equals minus 2, that'll be the vertical asymptote. and that's x equals minus 2. Now we need to mark the intercepts. So the only intercept we have is y. When x is 0, y is a half. If that's 1 and that's 2, a half is here. So that's the only intercept we've got. Now we can sketch the graph. The graph is coming from a positive y, infinity y, and it's going to be approaching at y equals a half, and then approaching the line y equals to 0 at infinity. The graph is also coming from negative x infinity, and then coming to approach the curve at x equals to minus 2, but never touches it. So the intercept point that we've got is only one point that we've got, which is x equals to 0 and y is half. And the equation of the graph we just plotted is y equals 1 over x plus 2. So question C, write column vectors, describe the translation in part A and B. For part A, the translation is moving the y, so we write, because x is not changing, so the x stays the same, and the y would change by 2, so we just put 2. That's the column vector for part A. For part B, the x is changed, so we're moving it by minus 2, because we set x plus 2 equal to 0, right? And therefore x equals minus 2. So we move the graph to the left horizontally by minus 2. So x changes by minus 2 and y doesn't change. And that's the vector column. When we write a vector, it's always x column y.